Right. So last class we had discussed this case, an object projected horizontally from a certain height. Okay. We derived a lot of things about this object. Fine. And in the worksheet, I had given you questions where an object is projected from a height, but not horizontally. It's projected like this. I think there was one question like that. Okay. And I've given you hints also. So it's easy only to deal with. You just have to write this initial velocity as a vector first in terms of its components. Then the height will be given. Height is nothing but displacement in the y direction. Using all that, you can find out the time of flight, range, such things. Okay. Acceleration is acceleration due to gravity. Consider that also as a vector. Fine. So any doubts or questions in projectile motion? If you have, you can ask. And I got answers to the worksheet only from one, okay, from one of you, Vanilla. Others, like during weekdays, you may not find time to solve those questions, but at least make sure by the weekend, okay, that week's work is complete. Don't delay it, because if you don't practice, you will not be able to remember. Anyway, let's continue. So there's one small point we missed out uh, about projectile motion in 2 dimensions, about ground to ground projectile especially. We'll discuss that quickly and then move on to relative motion in 2 dimensions. Okay. Now, suppose there's an object projected like this with a speed u at an angle theta above the horizontal. We know it follows a path like this and it strikes the ground somewhere here. Okay. This is what we call as the horizontal range. One of you quickly tell me, what is the formula for horizontal range?
U square sin 2 theta by g.
Okay, u square sine 2 theta by g. That is in terms of u and theta. You can also write it as 2 ux uy divided by g. Fine, correct. Now imagine this. If we project the ball with a certain speed at a certain angle, it will have a particular range. That's fine. What if, first case, what if theta is 0? How much will the range be? Anyone, if the angle of projection theta is 0, how much will the range be?
Sir, 0.
Okay, how do you justify that?
Sir, sin theta is 0.
Sine 0 is 0. Okay, so irrespective of the speed of projection, okay, doesn't matter with what speed you throw it. If you throw it at 0 degrees, okay, what is going to happen is this, like, okay, this is thrown at non-zero angle, that's fine. If the angle is 0, means it's projected horizontally, what happens is the object touches the ground at the immediate next point. Okay, it kind of moves on the ground only, right? So it touches the ground at the immediate next point. That is why the range becomes 0. Range is the distance from the point of projection to the point where it hits the ground. Okay, so for theta is equal to 0 degrees, the range is going to be 0. Okay, increase the angle a little bit. Okay, make it slightly non-zero. Then what will happen if you project it at a small angle like this? Then, like, the y component of velocity, uy, we know it is u sine theta. If angle is small, sine theta value will be small. Then the y component also will be small. And if y component is small, it won't have much time of flight. Okay, because time of flight we know is 2 uy by g. That is 2u sine theta by g. Okay, so if the y component is very small, time of flight will be very less. And in that small time, it will only be able to cover a small distance horizontally. Okay, so range will be less. It won't be 0, but it will be a small value. Increase the angle of projection. Keep the speed same. Okay, keep the speed same, but increase the angle of projection. Then there is a chance that range increases a little bit. Fine. So with the same speed at different angles, you get different range. Fine. Now we know R is equal to U square sine 2 theta by G. Suppose U is constant, fixed, and theta is variable. Tell me, for what angle will the sine function be maximum? Generally, sine of what angle is the maximum?
45 degrees, sir.
45. Okay, fine. Sine 90 degrees is the highest value of sine function that we can get. So you can say that range will be maximum when sine 2 theta is maximum. Okay, because for different values of theta, you'll get different values of sine 2 theta, and that will give you different values of range. So if you want range to be maximum, this function has to be maximum. Sine of any angle is maximum when the angle, that is 2 theta, is 90 degrees. 2 theta is 90 degrees, means theta should be 45 degrees. Okay, so what does this tell us? It tells us that for a given speed of projection, okay, the range will be maximum when an object is projected at an angle of 45 degrees. Let's assume this itself is the angle 45 degrees. Okay. Now what happens if you project it at an angle less than 45 degrees? With the same speed, less than 45 degrees, it will fall short like this. It won't have much, it won't go to much height because the y component will be less, and it will strike the ground like this. What happens if you project it at an angle greater than 45 degrees with the same speed? If you project it at an angle greater than 45 degrees, you will be giving it a strong y component, but the x component will become too short. Okay, x component is what makes it move horizontally. X component is what range depends on. Of course, it depends on time of flight. It also depends on x component. Now, if you make it more than 45 degrees, what happens is time of flight will increase, but x component will decrease too much. Then you will see something like this happening. It will fall short. Shorter than where it would fall at 45 degrees. Okay, so remember this point. For a given speed of projection, if you want the ball to land at the farthest distance horizontally, the angle at which it must be projected is 45 degrees. Fine. And see, this concept actually is quite old. You'll find this in every book. So they may not ask you many questions based on this. But what you need to know is how to find out the angle for which range will be maximum in any case. Now, this is a case of ground to ground projectile. For ground to ground projectile, this is the formula for range. And by looking at the formula, we are able to tell that this will be maximum when sine 2 theta is maximum. That happens when 2 theta is 90 degrees or when theta is 45 degrees. Okay, but that need not always be the case. For ground to ground projectile, this is fine. What I mean is, suppose an object, okay, just a moment, I'll copy one diagram. Okay, let's consider this case. Fine. So the speed of projection, okay, let's not even take it as 25, let's take it 20. The height from which it is projected is 60 meters. The question now is to find out the angle of projection such that the horizontal range is maximum. So we have to maximize this. Okay. Can one of you tell me an idea? Like for ground to ground projectile, we already derived the formula for range. We knew it was u square sine 2 theta by g, and we thought of how to make it maximum. So we know 2 theta should be 90, theta should be 45 degrees. Here, we don't have a formula for range. So if you want to find out what is the maximum range, not what is the maximum range, if you want to find out the angle theta for which range will be maximum, the first thing you need to do is derive the formula for R. So derive R in terms of theta. Okay, do this all of you. The speed of projection is 20, keep it 20 itself. The height from which it is projected is 60, keep it 60 itself. Try to derive an expression for range. I'll give you some hints. You can resolve the initial velocity into two components. Write the components, all of you. Once you do that, I mean, this is how we start solving any problem based on projectile motion. Okay, components are important. So write the initial velocity as a vector, some x component I cap plus some y component j cap you will get. And we know acceleration is downwards minus g j cap. I'm considering upward as positive y, so downward will be negative y. Okay. And when the ball goes from this position to this final position, it's effectively coming down by 60 meters. So we know displacement in y direction is minus 60 j cap. Okay. We need to use these to find out, to derive range. Okay. And range basically is displacement in x direction, which will be velocity in x direction multiplied with time. So you should first calculate time. How to calculate time? Sy is equal to uyt plus half ayt square. Okay, just write the equation. This is going to be lengthy. Okay, but try to derive some equation, all of you. Theta is unknown, so you will keep theta as it is. Don't substitute any angle there. Don't guess that it will be 45 degrees or 30 degrees or any. We don't know. We have to prove. Okay, we have to calculate. Okay. Pawan, tell me, how will you write initial velocity as a vector?
That 20 cos theta I cap plus
Correct.
20 sin theta j cap.
Okay, 20 cos theta I cap plus 20 sin theta j cap. So this is the x component of initial velocity and this is the y component of initial velocity. Acceleration, displacement are known. Okay, listen. This is going to be lengthy. I mean, it's going to be difficult to calculate also, but just look at the procedure. What we need first is t. Once you have t in your hand, you can put that and derive an expression for r, range. Okay. To get t, you will have to use the displacement. There is no other way. So you will be writing minus 60, that is displacement in y direction, is equal to initial velocity in y direction is 20 sin theta. So uyt plus half. Ay is acceleration due to gravity, that is minus 10 t square. Now if you see, this is a quadratic equation. Okay. But you have a formula for roots of a quadratic equation. Minus b plus or minus under root b square minus 4ac by 2a. So this equation can be rewritten like this. 2, this is 5. Send 5t square that side. So 5t square minus 20 sin theta into t minus 60 is equal to 0. So this is a. This minus 20 sin theta is b. and minus 60 is C. Okay, B is in terms of theta. Notice that A and C are constants, numerical values, but B is in terms of theta. Okay. Now you can write the roots of this equation. T will be minus B plus or minus under root B square minus 4AC whole divided by 2A. And you won't take minus because time taken for something to happen cannot be negative. You will take the positive root only. So I'll write plus here. Okay. But since B is in terms of theta, this will be in terms of theta. Okay. Let it be. Now what we want is the theta for which range is going to be maximum. Now you have to write the expression for range. Range is horizontal velocity into time. Horizontally, there's no acceleration. So it's just horizontal velocity into time. Horizontal velocity was u cos theta. And time, this value, you'll have to substitute it here. And then this whole thing will again be in terms of theta. Obviously, okay. The x component of velocity has theta term in it. The time of flight, time taken for the object to land on the ground, time of flight, yeah. This will also be in terms of theta. Okay. So we have range in terms of theta. Now what was our aim? Our aim was to maximize the range. Okay. Tell me this, all of you. We had discussed this long back in calculus. When you have a function y is equal to f of x, how to mathematically find out where y will be maximum? What happens at maxima? What is the mathematical procedure to find out the maximum value of a function?
Sir, first differentiation.
Good. After differentiating, what should you do?
It must be positive, means greater than 0.
No, 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 no. No. Differentiation means dy by dx. Dy by dx positive means y is increasing. Okay. That does not indicate maximum. Okay. See, whenever a function is a maximum or a minimum, okay, you can visualize it like this. X-axis, y-axis. Let's say the graph of the function is like this. Now this is the point where y is maximum, right? Wherever the function is maximum, if you draw a tangent, its slope will be 0. Slope of tangent becomes 0 at maximum, and at minimum also the slope of tangent becomes 0. Slope of tangent means what? Derivative becomes 0. Okay. So whenever something is maximum, its derivative becomes 0. That's what we are going to use. And the roots of this equation will give you the values of x. Where the function is a maximum or a minimum also. Now here we somehow will be able to write range in terms of theta. Now you want to find out the angle theta for which range is going to be maximum. Then what you should do is you have to differentiate range with respect to theta and equate it to 0. You will get the theta values. That's the mathematical procedure to find out the angle for which range will be maximum in any case. Okay, it's going to be very lengthy. I'll give you the steps in worksheet. You solve it once. Okay, but let us apply this approach to this case, ground to ground projectile. Like based on sine 2 theta function, we could tell that range will be maximum when theta is 45 degrees. Let's apply calculus now. Okay. Now in ground to ground projectile, we know range is u square sine 2 theta divided by g. Okay. Now we are assuming u is fixed. The speed of projection is fixed, but it is being projected at different angles. So theta is a variable. Theta varies, based on that range varies. U and g are constants. Okay. So it's like y is equal to some function of x. X is a variable and accordingly y will vary. Now our aim is to find out when the range will be maximum. Okay. For range to be maximum, derivative of range with respect to theta. Why with respect to theta? Because range depends on theta. It's a function of theta. Should be 0. Okay. That means the derivative of u square sine 2 theta should be 0. Okay. Okay. By g also is there. Now u square and g are constants. We'll put them outside the derivative. Now the derivative of sine 2 theta, should be 0. Okay. Can one of you tell me what is the derivative of sine 2 theta? How do we differentiate that?
Sir, 2 cos 2 theta.
Good. Good. I hope you all remember that derivative of sin x is cos x. Okay. But in place of x, you have 2x now. When something else is present in place of x, not just in this function, in any function, you apply the chain rule. Okay. You differentiate the outer function first, that's the sine function, and then you differentiate the inner part. Now derivative of sin x is cos x. So this thing's derivative becomes cos of 2 theta, and you multiply with derivative of the inner function. Derivative of 2 theta is simply 2. Okay. So this is what the derivative of sine 2 theta will be. And u square by g is there outside. This should be equal to 0. Now speed of projection is not 0. G is not 0. The number 2 is not 0 anywhere. That means cos 2 theta should become 0. Now cos of what angle is 0? We all know cos 90 degrees is 0. That means 2 theta should be 90 degrees. So theta should be 45 degrees. So using calculus, this is how you find out the angle for which range will be maximum. We took the case of a ground-to-ground projectile. For ground-to-ground projectile, this is the range formula. Differentiate it, equate it to 0. When you differentiate, equate it to 0 and find out the theta for which it happens, you see that it will be 45 degrees. Okay. So remember this, I'm explaining something general to you, not just in case of range. Generally, anywhere in physics, if you have to find out the maximum value of some quantity or under what condition some quantity will become maximum, differentiate the quantity, equate it to 0. Okay. Same for minimum also. Right. So ground to ground projectile, the range will be maximum when theta is 45 degrees. But if it's not a ground to ground projectile, if it's something like this, projected from a certain height onto the ground, then this need not be 45 degrees. In fact, it will not be also. I'll give you steps in the worksheet. For this same question, we will differentiate, we will equate it to 0, and we'll find out the theta for which the range will be maximum. You'll see that the angle won't be 45 degrees. Okay. Next, another small point. Again, range in case of a ground to ground projectile is u square sine 2 theta by g. We know that when theta is 0 degrees, the range is 0. When theta is 45 degrees, the range is maximum. Again, as theta increases beyond 45, the range decreases. Ultimately, when theta becomes 90 degrees, the range again becomes 0. What do we mean by theta becoming 90 degrees? Theta becoming 90 degrees means the object is projected this way. When you project something this way, what is going to happen? It will simply rise up and fall back to the ground at the same point. That is why when theta is 90 degrees, the range is again 0. Okay. So for different angles of projection, the range increases. For 45, you get the maximum range. Then beyond 45, the range decreases. As it decreases, what happens is, for another angle, you will see that the range is same. means the range that you get for one angle less than 45 will be same as the range that you get for some angle more than 45 also, provided the speed is same. Okay. And those angles will be complementary. Okay. Can any of you tell me what are complementary angles? Complementary angles.
So
Okay.
theta and 90 minus theta.
Complementary angles are two angles, the sum of which is 90 degrees. Okay. So suppose you take one angle theta and the other angle as 90 degree minus theta. In this case, the range will be u square sine 2 into theta by g. And in the second case, the range will be u square sine 2 into 90 minus theta divided by g. So it becomes, okay, left hand side, let's keep it as it is, u square sine 2 theta by g. Right hand side becomes u square sine 2 into 90 degrees is 180 degrees minus 2 into theta is 2 theta divided by g. And it is known to us, at least those of you who study trigonometry would be knowing, that sine of 180 degree minus any angle is equal to sine of that angle. Okay, those of you who don't know, you'll learn it in trigonometry. Fine. Sine 180 minus theta is sine theta. Sine 180 minus alpha is sine alpha. Similarly, sine 180 minus 2 theta will be sine 2 theta. So for the angle of projection theta and the angle of projection 90 minus theta, 90 degrees minus theta, you will get the same range. Okay, for example, 30 degrees and 90 degree minus 30, that is 60 degrees. The range will be same. 20 degrees, 90 minus 20, that is 70 degrees. The range will be same. Fine. You can even think of it this way. Like instead of theta and 90 minus theta, you can think of it this way. 45 degree minus alpha and 45 degree plus alpha, you will get the same range. For 45, the range is maximum. Okay. 10 degrees less than 45 means 35 degrees. And 10 degrees more than 45 means 55 degrees. They'll give you the same range. 35 plus 55, 90. They automatically become complementary angles. Okay. So, yeah. So this is something we missed when we discussed about range of ground to ground projectile. So what you need to remember is the range will be maximum for a ground to ground projectile when theta is 45 degrees, when the angle of projection is 45 degrees. And also you will get the same range for two different angles of projection. And the angle should be, when the angles are complementary. Okay. All this is valid only when initial speed is fixed. At the same speed, if you are projecting at different angles, then you can use these ideas. Because in the derivation, you must have noticed, we are assuming the speed to be constant. Okay. If they project with different speeds at different angles, there's no guarantee that, we cannot tell, like without knowing the values, we cannot tell in which case the range is going to be maximum. Okay. The next concept we'll be discussing is relative motion in 2 dimensions. Okay. Can one of you tell me how relative velocity is calculated? Like suppose you know the velocity of one object A and the velocity of one object B. How to calculate velocity of A relative to B? We had discussed this in relative motion on a straight line. Yeah,
Velocity
Pawan,
of
go
A.
ahead.
Velocity of B.
Can you repeat?
Velocity of A minus velocity of B.
Okay, correct. Velocity of A relative to B or velocity of A with respect to B is calculated as velocity of A minus velocity of B. Simple, whether it is 1D, 2D or 3D, this is the basic formula for relative velocity. Similarly, acceleration of A relative to B is the actual acceleration of A minus the actual acceleration of B. Okay, that's how relative velocity, relative acceleration are calculated. Okay. Solve this question quickly, all of you. Let's imagine a situation like this. Suppose there are two objects. Okay, one question like this was given in your worksheet also a few days back. But anyway, we'll discuss this case in detail. Let's call this as A and this as B. Suppose A is moving to the right with a constant velocity of 10 meters per second, and B is moving this way. Okay, you can say towards north with a constant speed of 10 meters per second itself. Okay, so you know their speeds, you know the direction in which they are moving. Calculate velocity of B with respect to A, and also speed of B with respect to A, velocity and speed. Can one of you quickly tell me how is speed related to velocity?
So speed is magnitude of velocity.
Speed is the magnitude of velocity. Instantaneous speed is magnitude of instantaneous velocity. So once you calculate relative velocity, take its magnitude, that itself will be relative speed. Do this quickly, all of you. Okay. Aishwarya, what is your answer for relative velocity?
Sir, is it 10 j cap minus 10 I cap?
10 j cap minus 10 I. Okay, I think that is correct only. What is the how do you write the actual velocity of A?
10 I cap.
Okay, 10 meter per second in the positive x direction, so 10 I cap. How do you write the actual velocity of B?
10 j cap.
Right. Okay, and then it's just a matter of substituting in the formula. You need VBA. It's velocity of B minus velocity of A. Velocity of B is 10 j cap minus velocity of A is 10 I. So you can write it as minus 10 I cap plus 10 j cap. Okay, usually we write it in this order: x, y, z. Okay, fine. Next is relative speed. Nitya, how much is the relative speed? Okay, use of any answer for relative speed?
10 j cap. 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 10 Sir, is it 10 root 2?
Okay, fine. So you just have to take the magnitude of this vector, and magnitude of a vector is the sum of, square root of sum of the square of its x component and the square of its y component. Whether you write 10 square or minus 10 square, it's not going to matter. It will be under root 200, that is 10 root 2 meters per second. That is how fast B appears to move as seen by A. Okay, it's not actually moving with that speed, but it appears to move with that speed. Okay. Now I have one exercise for all of you. There is, velocity of B relative to A, right? And clearly, this is not dependent on time or anything. So this is a constant velocity with which B appears to move as seen by A. Okay. Now let us make A the reference. A and B are both moving, but let's make one of them the reference. The object which we make as a reference never moves in that reference frame. Okay, this we had discussed in motion in a straight line also. No object can move away from itself, right? So no object can move relative to itself. Relative to surroundings, it may move. Relative to some other object, it may move. But an object cannot move relative to itself, right? So suppose A is made the reference. Okay. This is where A was initially, and that is where B was initially. Now, when you make A the reference, A will be fixed in that reference frame. It won't move. I want you all to draw or indicate in this diagram how B moves. Okay, do it yourself on the paper that you have. You know the velocity of B relative to A is minus 10 I cap plus 10 J cap. With this velocity, I want you all to just draw the path followed by B as seen by A. Okay, Nishita, are you there?
Yes, sir.
Generally, tell me, with a constant velocity, what kind of a path does an object follow?
Straight line.
Straight line. Okay. So velocity of B relative to A is constant, we have found out. Can you tell what angle that with this particular velocity, can you tell at what angle the object is going to move?
0.
Why will it be 0?
0 because it is a straight line, no, sir.
Straight lines can make any angles.
Okay, 45 degrees.
Okay, how did you decide it is 45 degrees? Answer is correct.
Like the constant velocity, the graph is.
No. And see, we are not drawing a graph. We are drawing the actual path followed by the object. Okay, fine. Let it be. Pawan, can you tell the angle at which this velocity points? Minus 10 I cap plus 10 J cap.
Sir, 45.
Okay, which way? I'll give you some options. This is A. This is B.
Sir, B.
B. Okay. Right. Minus 10 I cap plus 10 J cap. Minus 10 I cap will be this way. Plus 10 J cap will be this way. So effectively, the velocity of B with respect to A is like this. Okay. So as seen by A, B moves at an angle of 45 degrees. with the x-axis. Okay, it will continue like this relative to A. Let us understand why it actually is like this. I mean, you just imagine, suppose there are like, yeah, you just imagine them as two people. Okay, one person moving like this, one person moving like this. Now, when A continues moving the way he or she is moving, but observes B, it will appear as if B is moving at a 45-degree angle. Let's understand what that means. Now, you imagine an instant later, okay, or okay, let's consider this first instant. At the first instant, this is where B appears to be as seen by A. Okay, an instant later, A will move forward, B will also move forward. And if you see if you imagine A observing B with respect to A, B is now at an angle like this. Okay, and you can also observe that the distance has decreased. Fine. Next, another instant later, A will continue moving forward this way, B will continue moving forward this way. And now if A looks at B appears to be at an angle like this. This is the position of B as seen by A. Another instant later, A here, B here, and A observes B. This is the position of B relative to A. Okay, so these are all positions of B relative to A in the actual situation. Now let us take this to the relative frame, or let us put all that in the reference frame attached to A. In the reference frame attached to A should not move. Okay, so what we are going to do is we'll assume A stays at its position. So we'll remove all these. But we have to visualize how B appears to move as seen by A. So what I'm going to do is I'm going to move these vectors. At the first instant, B appeared to be along the x-axis. At the next instant, B appeared to be at some angle as seen by A. At another instant later, okay, B appeared to be at this angle, or at this position, not just the angle. Another instant later, B appeared to be here, okay, at this position as seen by A. This is what is happening actually as seen by A. Okay, so relative to A, B appears to be going this way. That is what we mathematically derived here. Okay, so let me repeat this. The object A is moving along the x-axis. The object B is moving parallel to the y-axis, okay, in the y direction. But as seen by A, B appears to be at different angles at different times. A is going straight in his own path. B is going straight in his own path. Okay, but when A continuously observes B is going off like this, so it will appear as if B is going that way to left. And also we can see that the distance seems to be getting shorter and shorter. Up to some time it will get shorter. So if you draw the vectors from A to B, that is the position of B as seen by A, and bring them all to the position of A, this is how B appears to move as seen by A. Okay, as seen relative to A will not be moving, and relative to A, this is how B moves. Okay, is this point clear to all of you? How we got, what actually relative motion means in 2 dimensions? We are just visualizing how one object appears to move with respect to another object. Fine. Now, in this situation, I'll ask you one question. Questions like this are also quite common, actually. You'll find in many books. But we have to do it. So, you know how A and B will be moving. I want you to find out the shortest distance between A and B. Assume initially they were at a distance of say some 200 meters. Okay, but we visualized later on B appears to be closer to A, right? Initially they were at 200 meters distance, that's fine. But sometime later, like you look at this vector, it doesn't seem as long as the first vector. Okay, so the effective distance between A and B decreases up to a certain extent. Okay, so I want you all to find out the shortest distance between A and B. I'll give you hints also. Listen. Generally, whenever you need to find out the shortest distance between two objects or the longest distance between two objects, or when two objects collide, okay, when two objects will be moving perpendicular to each other, and so on, you will use the idea, not will, the question will be simpler or the solution will be simpler if you use the concept of relative motion. Okay, you can solve questions without using relative motion also, but in such cases where you have to find out the shortest distance or when two objects collide and all, okay, when a car overtakes another car, such questions, if you use relative motion, the situation becomes simpler. Okay, so the steps you have to follow is follow are first visualize, okay, this part we have already done, how B moves relative to A. How do you visualize? You have to take velocity of B relative to A. To do this, that we have already done. Okay, next, draw the path followed by B. Okay, visualization is like drawing the path only of B with respect to A. And this also we have already done. Do it again, all of you. Mark the point on that path where B is closest to A. Next, calculate the distance between A and that point. Okay, if you can find out the point at which B is nearest to A, then finding out the distance between those 2 points is easy only. Okay, calculate distance between A and that point. Okay, do this all of you. First write the relative velocity, draw the path followed by B relative to A. Visually, just by looking at it, you can tell where B is closest to A. Okay, then try to find the distance between those 2 points. We'll have to apply a little bit of geometry, trigonometry also. Try this all of you. Any answer, anyone? I just gave rough ideas. I didn't give a thorough idea of what you should do. Okay, listen all of you. First tell me, like, you know how A and B are moving. Do you think there will be a shortest distance, I mean non-zero shortest distance between A and B? Or will A and B actually meet and the distance between them becomes zero at some time? Like we imagine them moving, okay, instant by instant. A is moving to the right side, B is moving in the north direction. So what do you think happens to the distance between A and B? Will it keep on decreasing and become zero sometime? Will it first decrease and remain constant? Will it first decrease and then increase? What do you think will happen?
So first it decreases and then increases.
Okay, Pawan, can you tell me one instant when do you think it will be increasing? Like here, the arrows that I have drawn, their lengths seem to be becoming shorter and shorter. When will it increase?
Sir, A అనేది B ని క్రాస్ చేసి ఇంకా వెళ్ళిపోతుంటారు సార్.
Okay. After some time, A will cross that initial position of B, you are saying. Okay. Let's say, okay, I'll mark them in yellow. Let's say A gets here, and by that time B is somewhere here. Okay. Obviously, they are moving with same speeds. So whatever distance A covers, the same distance B will also cover. Okay. In a given time, given amount of time. Now, if you see how B appears to A, it's like this. This is the distance between A and B, and it has increased. Okay, I mean, compare this vector and this one, right? So initially or up to some time, the distance between A and B will decrease, but after some time, the distance between them will start increasing. Fine. In fact, here itself, you can visualize, like consider a few other instances. Let's say maybe when A reaches here, okay, this point, and B reaches here. And A is here and B is here. You can already see the distance between them increasing. Fine. So the distance between A and B decreases for some time and then it starts to increase. So there is one moment, there will be one moment where A and B will be closest to each other. Is this point clear to all of you? Any doubt in this? We still didn't calculate, but are you convinced that there will be one instant when A and B are nearest to each other or not? Okay. If you have any questions, you can ask. The next thing we need to do is find out that shortest distance between them. Fine. Now, I gave you a few steps here to find out the shortest distance. We have to imagine how B moves relative to A. So we'll make A the reference frame. And when A is the reference frame, we know B moves at an angle 45 degrees. So maybe somewhat like this. This is how B appears to move as seen by A. And we got this angle 45 degrees from where? From the relative velocity. Minus 10 I cap plus 10 J cap. Okay. Next, draw the path of B with respect to A. path followed by B relative to A will be like this. Okay, continues at that 45 degrees. Mark the point on that path where B is closest to A. Now, general mathematics. A is one fixed point. B moves on this straight line. Can any of you tell me how to draw or how to mark a point on a straight line which is nearest to another point? Use of any idea? How to mark a point on a straight line which is nearest to another point out of that straight line? Nitya, any idea? Anyone? Okay, if you don't know that, then you won't be able to solve this question. Generally, see, if there's a straight line and there's a point outside that straight line, away from that straight line, and you want to mark a point on that line which is closest to this. Okay, let's consider different points. Call this A, B, C, D, and so on. Now, just by looking at it visually, you tell me which point on the line is nearest to this point X outside the line. Which point appears to be nearest?
Point C, sir.
Point C. Okay. Let us join X and C. C, like, C will be the nearest point to X on that straight line if this angle is 90 degrees. Okay. Any other angle, the distance will be more. Okay. So if you want to mark a point on a straight line which is nearest to another point which is not on that straight line, you draw a perpendicular from that point onto the line. So coming back to this question, you know how B is going to move as seen by A. We want to identify the position where B is nearest to A. Okay. Then what you should do is you should drop a perpendicular from A onto the path followed by B, straight line path followed by B. This is the position where B is nearest to A. Okay. Now we know this side of the triangle is 200 meters. Which triangle? This one. You effectively formed a right angle triangle. We know this side is 200 meters. We know this angle is 45 degrees. Can any of you tell me how to find out this nearest distance between A and B? The answer lies in this. I mean, you have to make use of this right angle triangle that you formed. How to find out this distance? In a right angle triangle, you know one side, you know one angle, and I'm asking you how to calculate another side. What can be done? Vanilla, any idea?
Sir, 745.
Trigonometry. Okay. Trigonometry relates, I mean, basic trigonometric ratios, they relate an angle and two sides of a triangle. Okay. Now you know one angle here. You know one side here. you need the other side. You just have to use the appropriate trigonometric ratio. That's all. Okay. So you can use sine 45 because for 45 degrees, this is the opposite side. And in this right angle triangle, this is the hypotenuse. You can do that and get that distance. Okay, if I do it here, sine 45 degrees is 1 by root 2. Opposite side is what we need to calculate, divided by hypotenuse is 200. Therefore, that unknown distance becomes 200 by root 2, that is 100 root 2 meters. That's the shortest distance between A and B. Okay, so listen, I'll summarize this. The question was to find out the shortest distance between two objects, and you were given how they are moving. You were given their actual velocities. You were asked to find out what is the nearest distance between them. So generally also, if you want to tell when an object will be nearest to another object, you should visualize the path followed by the object with respect to another one. So we first made one of them the reference, and we visualized how the second one moves with respect to the first one. How did we do that visualization part? We calculated the relative velocity. Using relative velocity, we drew the path that it would follow as seen by A. Okay, we drew the path that B would follow as seen by A. And along that path, we identified the position where B is nearest to A, and then we somehow used trigonometry to calculate that distance. Okay, let us do this in another case. Similar situation, but I'll change the values this time. Okay, I don't even have to show the y-axis. Let's say A is here, B is here. A is moving with a speed say 15 meters per second. B is moving in this direction with a speed 12 meters per second. Initial separation between A and B is, let's say, 120 meters. Calculate the shortest distance between A and B. Do this, all of you. Type your answers in chat. I'll give you 2 minutes. Any answer, anyone? You need to visualize how one object moves relative to the other and then do the calculations. Try. Or if you are stuck somewhere, you can ask. Okay, Yusuf, can you unmute? We'll discuss. No response. Nishita?
Yes, sir.
Huh. So how did you start solving? Or
I
okay.
actually didn't get
Huh.
how to solve it, sir.
See, the question is to calculate the shortest distance between two objects. Okay. I mean, it's the same question like the previous one. Whenever you need to find out the shortest distance, like the moment when two objects will be closest to each other, the moment when one object overtakes another, meets another, such questions, you use relative motion. Okay. You make one of them the reference and you imagine or visualize how the other one moves with respect to this reference. How that is done, how that imagination is done, is by using the relative velocity. Okay, if you know
Yes,
relative
sir.
velocity, you can tell how the object will. Yeah, what did you say?
K as reference.
You took A as reference. Okay. So if you take A as reference, then in that frame A will be at rest. How much is velocity of B relative to A? Let's take A as a reference. Then in that frame, A will not be moving. And in that frame, you need to visualize how B moves relative to A. So Nishita, did you calculate velocity of B relative to A?
-3.
Minus?
3.
Where did 3 come from? A's actual velocity is 15 meters per second. B's actual velocity is 12 meters per second this way. Okay, you just did 12 minus 15. No. Velocity is a vector quantity. You have to assign direction. So Nishita, tell me, what is the actual velocity of A?
15 I cap and
Ha,
12 J cap.
ha. Actual velocity of B is 12 j. Now subtract them. What is VB minus VA?
12 J cap minus 15 I cap.
Okay, so minus 15 I cap plus 12 J cap. That is velocity of B relative to A. Okay, this is a very common mistake. In a hurry, students tend to subtract the speeds and take that as relative velocity. That is not correct. Velocity is a vector quantity. You have to treat it as a vector quantity. Okay. We got velocity of B relative to A. This will help us imagine or visualize how B moves relative to A. Now this is a constant velocity. Means B moves on a straight line. The angle made by that straight line is what we need to calculate next. We need to know exactly how B moves relative to A. Okay. So we have to draw this vector. Minus 15 I cap will be this way. plus 12 j cap will be like this. 15, 12, 12 has to be slightly shorter. Okay, so minus 15 I cap plus 12 j cap. So the relative velocity of B is actually like this. Okay, minus 15 I cap. Okay, just a moment. Plus 12 j cap. This is the velocity of B as seen by A. Okay, let us put that vector here. Just a moment. Okay, never mind. Okay, it's a straight line anyway, so can take it like this. So with respect to A, it will move along this direction on a straight line. Now, what is it that we need to calculate? We need to calculate the shortest distance between them. The next thing is to visualize that shortest distance. As B moves along that straight line as with respect to A, or as seen by A, the shortest distance between them would be the length of this perpendicular drawn from A onto that path followed by B. Let's call this distance as X. X is what we need to calculate. And you again find that there is a right angle triangle forming. You already know one side of that right angle triangle. The only extra thing you need to know is some angle somewhere. And then you can derive X using trigonometry. Can any of you tell me the angle at which B moves relative to A? Okay, why are we only bothered about that angle? Why not other angles? Because we know only that vector. We know velocity of B relative to A, so we should be able to tell at what angle it moves. Okay, so one of you do this calculation. At what angle does B move relative to A, relative to the x-axis? Or can one of you quickly tell me how to calculate that angle?
So tan theta
Tan
equals
theta
4 by
equals
5.
Good. From this vector diagram, you can get that. Call this angle alpha. Tan alpha is opposite side 12 divided by adjacent side 15. Okay, so that's like 4 by 5. Let it be. Doesn't matter. We know tan of that angle. Okay, so indirectly we know the angle. Fine. You may not be able to tell the exact angle. Let it be. Like you may not be able to tell that it is so and so degrees. That's fine. But you know tan of the angle 4 by 5. Okay. Now tan relates opposite to adjacent. But we don't know the adjacent side. We know the hypotenuse. The only thing we can use here is sine alpha. Opposite by hypotenuse. Okay. Another mathematical idea here. If you know tan theta as A divided by B, can one of you tell me how much sine theta is? Like how to calculate sine theta? If you know, you know, otherwise you don't know. So if any of you knows, you can tell. From tan theta, how to get sine theta value?
So sin theta is first A.
No, sine theta need not be A. In that case, Pawan, we got tan alpha 4 by 5. That means you are saying sine alpha is 4. How can sine of any angle be 4? Okay, it's not like that. Why it is not like that also I will tell you. See, tan alpha or tan theta is A by B. This can also be written as A by some constant divided by B by some constant, and that constant got cancelled and you got it as A by B, right? This is the value of sine theta. And this is the value of cos theta. But how to get that C? Okay,
Sin theta is a by root a square plus b square.
correct. So remember this in general, all of you. If you know tan of an angle, you can tell sine value and cos value, and this is how it is done. If tan theta is a by b, sine theta is a by root of a square plus b square. And cos theta is b by root of a square plus b square. I can explain this, but mathematics, let us not get into that. So here we got tan as 4 by 5, tan theta as 4 by 5. So use that logic, all of you. Tan alpha, we got 4 by 5. So tell me how much is sine alpha. Pawan, you only tell directly based on the formula.
Sir, 4 by 3.
4 by
3.
where did 3 come from? We use this, no? Why should it be 4 by 3?
Sir, 4 by root 34.
4 by root of 4 square plus 5 square, 16 plus 20. How did you get 34? (16 plus 25, 41. Anyway, we got sine value. This is 4 by root 41. Then we can tell the distance x. Okay. Listen, like from your response today itself, I'm telling this to everyone. I can tell you found this a little difficult, especially that relative velocity part. Not an issue. I'll send you a recording of this lecture. You go through it once. First, we discussed how to find out, or not how to find out. First, we discussed when the range of a ground to ground projectile will be maximum. Okay, 45 degrees. We used two methods to prove that. One is by thinking when sine function will be maximum. Okay, since we already know that. We got 2 theta 90, theta is 45 degrees. Another way we proved it is by using calculus. We differentiated the range function, equated it to 0, and we saw that theta should be 45 degrees. Okay, so for range to be maximum, theta has to be 45 degrees, but that is for ground to ground projectile. What if it is ground to some other point? Okay, and see, some of you are preparing for NEET. Those of you preparing for NEET, you don't have to bother about this. I mean, it involves too much mathematics. In NEET, they don't ask you in that much depth. Okay, but those of you who want to become engineers, you will have to do this. Okay. So the question here is, if it is not a ground to ground projectile, what is the angle for which range will be maximum? So we used a general procedure for it. We want range to be maximum. On what factors does range depend? You have to think. It depends on this angle because the other values are fixed. Speed, height, gravity, they're all fixed. So the only thing left is angle. So where the ball lands depends on the angle at which you throw it. So if you want to find out when the range will be maximum, you have to express the range in terms of that angle. Generally also, if you want to find out when a quantity will be maximum, you first find out the factors on which the quantity depends, then you write a function relating them. Okay, so here we had to write a function relating range to theta. We did that. I mean, we didn't do it completely, but we discussed how to do that. Okay, in the worksheet, I'll give you step by step. You can do it on your own. Once you get range as a function of theta, the next thing you need to do is differentiate it, equate it to 0. Then you will find out the theta where range will be maximum, or for which range will be maximum. Okay. And we also discussed that range will be same for two different angles of projection, provided the speed of projection is same. And the two angles will be complementary in nature, or they'll be of this form, 45 minus alpha, 45 plus alpha, or theta and 90 minus theta also you can take. Next, we started discussing relative motion in 2D. We considered one case today where we knew velocities of two objects and we had to find out the shortest distance between them. Okay. Fine. This is one particular case. Actually, it's like you will find many questions like this in like previous year questions and all. Next class, we will discuss relative velocity between rain and a man moving in rain. Okay, rainman problems. And if time permits, we will also move on to river boat. How a boat can cross a river in shortest amount of time, in the shortest path possible. Okay, how much time it takes for the boat to cross a river. Such cases we will discuss. Okay. Fine then. Thank you all. We'll continue in the next class. Next class will be on Friday. Okay, almost same time you will have. 7 or 7:30 the class will start. Okay, and as I said, last worksheet I got answers only from, just a moment, let me check. Vanilla had sent. That's all. I got answers only from one of you. The others solve those questions. Okay. Because again, same thing I'll have to repeat. Without practice, this will all be useless. Or you are learning something at school or college. You are learning something from me. But somewhere you have to put it to use. Only then you will be able to remember and finally solve questions in the exam. Okay, then we'll continue on Friday.
Sir?
Thank you all. Yes.
Can you post the second year videos also in YouTube or something?
They are there, not from the beginning, but right now current electricity chapter is going on. They are there on my channel. It's a different channel. I'll send you the link.
Okay, sir.
Okay. Okay. Thank you all. We'll continue on Friday.
Thank you, sir.